talking, it occurred to me that one of the cool things that you could replace in the human body, that's essentially, it was originally an interloper to begin with, a bacteria, but the mitochondria in our cells, generally our cells run on ATP, and the actual burning of food and oxygen together to get energy is mostly done in the mitochondria, where the metabolism happens and the mitochondria produces ATP. Well, I showed a picture of the molecular machine in the mitochondria that actually does that. But you could build one, and the mitochondria would be actually completely replaceable by similar machines, but B, you can make machines that were a lot more reliable than the mitochondria, because the DNA in the mitochondria doesn't have anywhere near the safety features and self-repairing capabilities that the DNA in the cell's nucleus have, because they're descended from bacteria rather than all the animal forebears that we have. So if you're getting all the way down to the cellular level, the mitochondria are a prime candidate for replacement by nanomechanisms. And basically, if that happened, you would just have energy like a little kid all the time. And it would just be a much more wonderful sort of life, I think.
I think we pretty much all agree that the medical side is going to be huge. So let's maybe look at some other areas as well. So I mentioned instrumentation. I mean, nowadays you can have a Wi-Fi chip the size of a grain of sand almost. And so you can imagine, again, all these nanosensors with the ability to communicate using Wi-Fi or Bluetooth or whatever, basically all over anything, really. Let's talk about maybe airplane structure. Okay, so a lot of times you have these metal fatigue problems, but if they're covered with these nanosensors, if there's a crack anywhere in the plane, you would know instantaneously because they would sense that. Okay, so and other things too. Let's say like there's apparently something called the Jesus nut in helicopters. It holds the rotor to the helicopter, and if that breaks, you'll be seeing Jesus pretty soon, because that's basically holds the blade to the helicopter, and if it fails, the helicopter falls out of the sky. So again, if you could have these sensors attached to that component, any kind of a micro crack or anything would be noticed very quickly, and then obviously you want to maybe land very quickly as well to avoid something catastrophic. So again, there's tons and tons of applications for these sensors. I think that would be kind of a really cool thing to look forward to when we get that technology perfected.
I believe that nanotechnology will be one of the pillars of the next 20, 30 years, actually more than that, in our society. It will change completely the way we manufacture our products, the way we design our products, and the way we utilize our products. Not only from the medical point of view, but also from the industrial and manufacturing point of view. At the same time, we also have to consider the, as I mentioned previously, the ethics. We have to consider the dangers that we may face. For instance, if we can, let's say, if we could utilize nanotechnology to replace our neurons in our brain or something like that, we will have an artificial or semi-artificial human. We can have a person which is built with, let's say, artificial organs, with nanotechnology, and also an artificial brain. So we can have something which I cannot define as human, I cannot define as robot, I don't know how to define it.